Okay. So hopefully now it will not flicker. So let's say we bought a box from somewhere, right? And we know that the box probably has some voltage sources, current sources, or some resistances inside, right? So we would like to establish. I know it has some sources inside. I don't know whether it's a voltage source or a current source, right? But for our purposes, it doesn't really matter because all we want the box is to do some job for us, right? So it has to drive some resistance, for example, in this case. So what I want to understand is, let's say I have a resistance RL. Can I figure out a way to understand if this box behaves like a voltage source or if this box behaves like a current source? Right? So let me rephrase the question. So let's say I went to one of your EC labs or 380 labs or any one of the labs. They have these big equipments which are supposed to power up your circuit, right? So I take one of those circuits, one of those equipments, and I connect an RL, right? And let's say the box says that it is supposed to be a voltage source of value 10 volt. It is supposed to give me a constant voltage of 10 volt. That's what a voltage source is, right? So I connect a value of RL and I see it's not giving me 10 volt. So then can I assume that the box is a good voltage source or it's a voltage source? So let me ask you another question. So before I repeat, let me ask you another question that what do you understand when I say that something is a voltage source? It has constant voltage with respect to something or it has constant voltage period? Right. It has a open circuit constant voltage. Any other comment? So let's say I take a capacitor. Let's say I take a capacitor which is charged to, let's say, 1 volt. It's open circuited. Will the voltage remain constant? Yes. So is this a voltage source? No. Why not?
Discharge.
Where will it discharge? Moment I connect anything, moment I draw charges out, moment I load the circuit, it is going to discharge. Or in other words, I can say that voltage will not remain constant. So what is now if I have to redefine a voltage source, can you make a better definition of a voltage source? Right. It provides a constant voltage no matter what type of load that I am connecting to it, right? Okay, which means that in current voltage parlance, it should keep the voltage constant regardless of whatever current that you are pulling out of it. Okay. So now somebody claims that the stuff inside the box is a voltage source. It's supposed to give you 10 volt constant voltage, but I connect RL. Let's say I say that I connected RL and for a range of RL, it is constant, right? So let's say for RL between 1 kilo ohm to, or let's say not 2, let's say for RL greater than 1 kilo ohm, V0 is approximately 1 volt. And for RL much less than 1 kilo ohm, V0 is, let's say, proportional to RL. This is an observation, right? You plugged it in the net, plugged your network with the RL, and you changed RL, and you saw some behavior like this. So now, can you comment on whether the stuff inside the box is a voltage source, current source, mix and match? What is happening? So if it's a current source, one of the answers was a current source. If it's a current source, let's say it's a current source, so which means that it is something like this. I not RL. So if I change RL, do you expect the voltage to be constant? No, right? So it cannot also be a current source because I see that for a range of RL, for RL greater than something, or let me say much greater than this. It's not a hard limit. So let's say for RL much greater than 1 kilo ohm, I see the voltage to be constant. And for RL much lesser than 1 kilo ohm, I see the voltage is almost like proportional to RL. By the way, in this case, in this current source case, the voltage will be proportional to RL. Right? If I change RL, the voltage is going to change. Correct? So looks like from this observation, the stuff inside the box is a current source. And looks like from this observation, the stuff inside the box is a voltage source. Right? So can you comment what's happening? By the way, these are approximately 1 volt or approximately, it's not exact, right? So engineering is about a lot of approximations. So what do you think is happening?
We label them for different ranges of power. Like for greater than 1 kilo ohm, we can label it as a voltage source.
Right. So your answer is, your comment is, we label the stuff inside the box as voltage source for greater than 1 kilo ohm, and correct, I agree. So that is from the perspective of the consumer, right? So I bought it and I see that this observation, then I tell myself that for this range, I'll use it as a voltage source for this range. Correct. So now, but I want to get inside the box and understand what's there. What is making it behave like this? Voltage source with internal resistance, great, but I would like to probe again. Why? Why do you say so?
The resistance would be close to the, let's say, the R per.
Okay, great. So now let's see. So this has made my life a lot easier. So let's say I have an internal resistance, source resistance RS. I have a voltage source. So and I have an RL. So for, let's say RL is equal to 1. I mean, much greater than 1K, let's say RL equal to 10K. Right? And let's say this is 10 volt. So can you tell me some approximate value of RS for which V naught will be approximately 10 volt? Yeah, something that is much lesser than RL, right? So RS is much lesser than RL, then V naught will be approximately 10 volt. Correct? So now let's come to, this is understood, right? So now let's come to the other thing, right? What are you observing? The other observation is when RL is much lesser than 10K, right? So this is much lesser than 10K. We are observing V naught to be proportional to RL. Now, why is that happening?
RL and RS are comparable.
RL and RS are comparable. Okay, so let's say RL is equal to RS, right? So in that case, it's 5 volt. So yes, there is a voltage divider, correct? So let's do that. It's a simple math. So let's do that. V naught is equal to 10 volt times RL by RL plus RS. Now, if I put the constraint that RL is, let's say, much less than RS, what do we see? Then V naught is approximately equal to 10 volt times RL. Correct? Right, sorry. Yeah, obviously. Otherwise, even the units don't match. Thank you. So V naught is proportional to RL, right? We are changing RL. RS is the stuff inside the box, right? So this 10 volt by RS is not in our control. That is inside the box right now. So this observation holds. Correct? So now, can you tell me, is this a voltage source or a current source? But I have not opened the box and seen it inside, right? So it can as well be something like isn't it? So what I'm essentially getting at here is In this case, if you impose the condition that RL is much less than RS, where will this current I0 choose to flow? This current I0 comes to this node and it has a decision to make. Should I go into RS? Should I go into RL? It should choose to flow into RL. Almost the entire thing will choose to flow into RL. So if it chooses to flow entirely into RL, so then naturally the voltage here becomes proportional to RL. But if RL is much greater than RS, right? So maybe use a different color. If RL is much greater than RS, then where will it choose to flow? Into RS. And regardless of I keep on changing RL, the voltage will not change. So now is the stuff inside the box. What is the comment? Is it a voltage source or a current source? Right. So essentially it can be anything. We don't know. But what we know is the stuff inside the box can behave like a voltage source or it can behave like a current source depending on how you load it. Right? So there is no ideal voltage source, there is no ideal current source. You can make any realistic voltage source work like a current source if you change the load. Or if you can make any realistic current source work like a voltage source if you change the load. It's all about loading. Okay, make sense? So now let's flip the argument on its head. And I say that I want to build a voltage source. I want to build this box. I want to build a voltage source. And I know that RL has a range of RL goes between 100 ohm to 1 mega ohm. And I know that I cannot build an ideal voltage source. That doesn't exist. I have to build a realistic voltage source. So can you comment on one most important aspect of the voltage source that I would like to design for? A voltage source has obviously a voltage source and some internal resistance which you cannot do away with. But maybe the internal resistance I can control. So if I can do that, what comment can you make on the internal resistance of the voltage source? It should be much less than the minimum RL. Right? So if I have to make a voltage source, this course is about designing the stuff inside the box. So if I have to design the stuff inside the box, I need to know what am I designing for. So you start with the answer, right? As I said, you start with the answers. What is the answer in this case? The answer is I need the output to be, let's say, a 10 volt constant, regardless of RL changes between 100 ohm to 1 mega ohm. So what is the first step back? The first step back is to understand what should be the internal resistance of the voltage source that I am trying to build. So the specification for the internal resistance of the voltage source should be much, much lesser than RL. In this case, minimum RL, which is 100 ohm, right? Much lesser than 100 ohm. Make sense? Extremely important concept. If it's not make sense, I will repeat. Very simple concept, but extremely important. Does it make sense? Okay. So now we all understand when we say something internal resistance is a voltage source and some series resistance and so on. But there is a different term that we normally use in circuit design. The resistance which essentially we are looking at is a resistance that is looking into the port, and that essentially is the Thevenin's equivalent resistance. Right? So whatever resistance that you are looking into the port, right, that essentially means open circuit resistance or Thevenin equivalent resistance or finding out any resistance inside a port that you have done in your earlier courses. Right? I presume you have done finding out resistances of a network. Right? So essentially this, whatever is equivalent resistance that you are looking at, if we call it Thevenin equivalent, so all you have to ensure that if you are trying to build a voltage source, the Thevenin equivalent resistance is much lesser than the load that you are driving. Okay. So the reason I am harping on this extremely simple concept is to motivate why finding out resistances is a very important skill to have. Right? You find it, if you try to design any circuit, you have to fix on some architecture. Initially, we will give you the architecture. So if we give you the architecture, you should be very proficient in finding out resistances. And I again, I assume that you have done finding out resistances of control sources when you have control sources in the network, right? Voltage control, voltage source, voltage control current source, and so on. You have done that or no? Yes, right? So this, the tutorial one that got posted was essentially a revision of what you have done earlier, just to give you an idea of what we expect, right? Your proficiency should be such that you find the stuff in the tutorial to be really easy, right? So let's take an example of a circuit which has some control sources, right? And let me show you how I expect you to go about finding out resistances, right? There are a number of ways of finding out resistances, but one that will be useful for this course is something that I would like to show you. So let's say I have a box, and I want to find out the resistances. So tell me one way that you are comfortable with. I want to find out the resistance.
Short and open or sources in the-
Fine. So I have sources, correct? So I short the voltage source, and I have a current. If I have current source, I open the current sources. Let's say I had a current source, I open the current sources. So then what next? Good.
and temporary source.
You add a temporary source. Great. Voltage source or a current source? Anything, doesn't matter. Let me add a voltage source. So I call it V test. This is a test source we are adding because this is not a part of the circuit, right? So we are adding it explicitly for some purpose. We added a V test. Then what are you observing? We solve for KVL, KCL of this entire network, and I find out some current. I call this I test. And then what? Right? So equivalent resistance will be V test over I test. Again, extremely simple, trivial stuff, but let's do one example. So let's say I have a voltage controlled current source. So let's say I have a voltage controlled current source. And I name it like G as in conductance. So let's say this is terminal A, this is terminal B. This is G A B times VA minus VB. And I apply voltage source here. This is the input, this is RS. And let's further assume that these two terminals are shorted to ground. Okay. I want to find out what is the Thevenin's output impedance. What will it be? Can you find out and tell me? Will you find it? Huh? Okay, so let me help you. So what is the first step? First step is desensitize the sources. Correct? So what is the source that we have here? VI. Desensitizing VI means setting VI to 0. If I set VI to 0, what happens there? It becomes short. What is the second step? Put a voltage source, and you guys only told me, right? So I'm just following what you told me. So put a voltage source, V test, and what should I observe? I should observe this current, and let me call this I test. Correct? Okay, so this is my setup now. So I have to solve KVL, KCL for this guy. Correct? So now what is VAB now? VAB is 0. If VAB is 0, what happens to, so what, by the way, what type of source is this? Yeah, it's a dependent current source, right? What is it dependent on? Which voltages? VAB, and VAB is 0, which means what should I do with this? It gets opened, right? So essentially this becomes open, so this goes off also. So it's an open circuit. I apply, then what will be I test? 0. Then what is the impedance? What is RTH?
Infinite.
infinite, right? So your RTH will be infinite. Okay? Yes. Correct. That is a dependent current source. What is it dependent on? So what is it? We are not opening because it is dependent. We are opening because the stuff that is dependent on got to zero. Right? VAB becomes zero. Then this current becomes zero because this is VA minus. Yeah, that is a very important question that she asked. I assumed you know this, but still, let me just make it crystal clear. When we short and open sources, we short and open independent sources, not dependent sources. Right? Okay, fine. So let's do another quick example because I don't want to start something right now. Let's take a similar circuit. And now let's assume that we have a resistance here. So let's say this is R1, this is also R1, this is VI, and I want to find out RTH. This is G times VAB. That is VA minus VB. So what should I do? First thing, desensitize the source, which means this goes shorted. I redraw the same circuit. VA, this is VB, this is GVAB. And then what? Yeah, I apply a voltage source, V test, and I find out the current I test, right? So now, I mean, taking leap from just the previous question, the previous example. Now, will this current source, dependent current source, exist, or will that go to zero? Why will it exist? Correct, right? So now VAB is not zero, right? Because now there is a path for the VTest voltage to develop a voltage at the node VAB. So can you quickly do the KVL, KCL of this and tell me what will be RTH? So one general tip about doing analysis in circuits is try to do the analysis on the circuit. I mean, not necessarily writing out big equations, right? Try to minimize equation by doing the KVL, KCL on the graph itself. I mean, what I essentially mean is that in this case, for example, you have V test. So what will be this current? This current will be V test by 2R1. Correct? So this voltage will be what? This voltage will be V test by 2. Right? If the VAB is V test by 2, what is GVAB? This is G times V test by 2. So what is I test? I test, there are two components. One component flows here, other component flows there. So I test will be V test by 2R1 plus G V test by 2. So what is I test over V test? Is 1 by 2R1 plus G by 2. So this is your effective GTH per se, right? 1 over that will be RTH, right? Right? Okay, we'll stop here.